All right, for number 14, 10 to the third power means you're going to do 10 times 10 times 10. So that's like saying I'm doing 1 times 1 times 1, which is 1, and then I have 3 zeros that I have to put on the end. So I end up with 1,000. Another way of thinking of it is you could think of it as 1 times 10 to the third power. So the decimal's behind the 1, and then you'd have to move the decimal 3 places. So that's just another thought process. Number 18, if I wanted to write 0.01 as a power of 10, well, I would have to move the decimal twice over, so I know my exponent's going to be a 2, and because this is a number that's less than 1, I know my power of 10 has to be negative, so it would be 10 to the negative second power. 27, you have to list those numbers from least to greatest. So what you do is you look at the exponents first, because every one of these numbers is in scientific notation. The first number is a number between 1 and 10. So that was the key, that I could just look at the exponents. So when I look at the exponents, that's got a negative 3 on the 10, that has a negative 3 on the 10, and that has a negative 3 on the 10. So negative 3 was my lowest exponent, so now I order the number that's between 1 and 10. So 1.23 is the smallest out of those, so I'd have 1.23 times 10 to the negative third. Then the next smallest number is 1.32 times 10 to the negative third, and then 3.12 times 10 to the negative third. Then I look at the next lowest exponent, which is a negative 1. So that has to be my next number, so 2.13 times 10 to the negative first. Then the next lowest exponent is the 1, so I'd go 2.13 times 10 to the first power, and my highest exponent was the 2. So my last number is 3.12 times 10 to the second. And then number 30, I have to write that number in scientific notation, so you have to have a number that's between 1 and 10. So 4.008 is a number between 1 and 10. So basically you got to have one digit in front of your decimal. Then you got to say, well, how many times did I move that decimal? Well, I went 1, 2, 3, 4, 5, 6, 7, 8. So this would be times 10 to the positive 8th power, because 40,080,000 is a very, very big number, so you had to have a positive exponent. Okay, for number 11, you have a negative exponent. So when you have a negative exponent, you have to flip it upside down to get the exponent to be positive, and then 4 times 4 is 16. So you end up with 1/16. Number 20, I have 2 times x to the 0. X to the 0, anything the 0 power is 1. And that y to the negative fourth has to be flipped to the bottom, because it was a negative exponent. So it goes down to the bottom, so my final answer is 2 over y to the 4th power. Okay, for number 9, I need to graph that system of linear equalities. They're both in slope-intercept form. So on y is greater than 2x plus 3, my y-intercept is 3. So I can put a dot at 3 on the y-axis. My slope is 2, so I can count up 2, right 1. I can do this a whole bunch of times. Because it's just a greater than symbol, I'm going to use a dotted line. So there's my dotted line. It's greater than, which means I'm going to shade above the line. That only worked that I could know I'm shading above without doing a test point, because it was in y equals mx plus b form. Then my other line is y is less than 2x. I can put a plus 0 on the end here, so I know my y-intercept is 0. And then I have to count for up 2 over 1. And once again, this is just a less than sign, so it's dotted again. And since it's less than, this time I shade under the line. So the question is, where does yellow and blue make green? It doesn't. So the answer to the question would be no solution.